Hi, I'm John Riley, and this is Calculus of Econ. Suppose you knew nothing about calculus and you're given a profit maximization problem. I want to convince you right now that you could solve it using Excel. Open a spreadsheet, as I've done, and here's the example. In the example, the firm is small in the marketplace, so it can't influence the price. Revenue then is price times quantity, and there's a cost function. I'm going to allow the cost function to have a constant term, a linear term, a quadratic, a cubic, and a quartic, although in the first example over on the right, I'm going to look at a simple case where there's just a linear term and a quadratic term. And notice how in Excel you write a multiplication sign and x cubed and x4 using this hat. And let's get started. We need to pick some numbers, so I'm going to assume in example A that the output price is 81. There's no fixed term. There's a linear term of 20x and a quadratic term 2x squared. And then I'm going to pick any number. Let's say take 4. I need to compute the formula for profit at that output, and here it is. The price is A10, cell A10, times the quantity, which is cell I10. There's the revenue. And then I've got all these terms, starting with C10, the fixed cost, and then D10 times X, which is I10, and so on. So that's the formula. So all we have to do in this cell over here, I'll click on it, and we can see it all written out here. And it's also written up on the formula bar up on the top. And you see then that if you compare it with the formula on row 6, that they should be the same. So all that you need to do, if I hadn't typed this in, is type in that formula. So now we've got the profit when the output is 4. So to figure out the maximum, we could just try different numbers, say 5, and say, that's better. The output has gone up to 255. I'm going to improve on that. I'm going to consider an increment, pick any number you like. I've chosen 3 here. And then we're going to compute the output at that incremental. If we add to 5, the increment of 3, so right now equals, here's our first formula, equals this quantity plus this quantity, enter. And now we've got 2 numbers, x0 and x0 plus delta x, and we need to put the formula in here. You could type it out. It's A10, it's following from over here. It's A10 times I14 plus C10 plus D10 times I14 and so on. But I don't want to do that. I want to do a shortcut, so I can Control C and Control V. I don't believe that the answer should be 0. Let's have a look up here and see what the formula is. It's A14, I14, so that's not correct. It's cell A14 is a blank cell. So we've made a mistake. And here's the problem. When we start here and copy under Excel, if you copy a formula like this with 10s, go down 4, all the 10s are going to become 14s. And we do want I10 to become I14, but the others are parameters. They're fixed. So let's show you how we can make them fixed. So while on this cell, I'm going to go up to the formula bar and click on or right beside all the terms one by one that are constants, and then hit the function key F4. I'll do that, and notice that perhaps you can see it up here, you can see it even more clearly down here. It's both the column and the row 10 have got dollar signs, and this freezes both of them. So that's what we want to do. So we're going to repeat this exercise, go up to here and hit the F4 key, and then over here hit the F4 key, and then over here I'll go right beside this time, hit the F4 key, hit the F4 key, hit the F4 key, enter. And if I click on the cell, you see now that all the terms that our parameters have been frozen. Now Control C for copy and Control V for paste, and that I believe. So let's put in here the difference in the y. We've got the difference in x, 5 and 8, and now the difference in y, it's equal to 360 minus 255. There it is. And it will be helpful to think about the rate of change. That's delta y over delta x. So just write equals 105 delta y divided by 3 the delta x. So now we've got a way of working our way to the maximum. Starting at 3, we notice that 8 gets you more than 5, so I may as well put the 8 in here. And now we notice that the rate at which the output is going up is still positive. It's 23. So we can, 11 is better than 8, so I can go up to 11. And hit the enter key again, still positive, 14. And now it's negative. So it doesn't, it's less profitable to go from 14 to 17. I could make this smaller, like 1. Now check it. And now it is more profitable to go to 14 to 15. So we know that we've got a pretty good idea that 15 is better than 14. What if we go from 15 here and look at 16? 16 is worse. So it seems that the maximum is around 15. So we've made some progress. We could make this increment smaller and smaller and work our way, take a little, if it's positive, make an increase in x. If it's negative, make a decrease in x. And we could feel our way to the maximum. But I've got a better way. So let's have a look at the second sheet. It's the same data, and what I've done is draw 3 curves, and here they are. The first one is blue. That's the function. So I've drawn the function between 0 and 25 in the blue curve. I've taken the two I've drawn 2 markers. It's this point, x0, 9 and 387. And then I've taken this point, 12 and 444, and I've popped them into the same picture. And finally, I've drawn a line through those 2 points. So with this figure, we're going to find it much, much easier to get a very accurate estimate of the output that would maximize profit. So let's look at this figure in sheet 3. So I can see that going to the right, we know it's going to be somewhere up to 15, and I've got this line which indicates it's the extension of the chord joining these 2 points. So why don't we reduce this to 1? Okay, and then we could go up to, we know we start go over to 14, let's say. So we know we're pretty close to the maximum, but it's getting a little, let's go make it even smaller, 0.1. All right, so the 2 dots are hardly visible, but we can see what the extended chord looks like. I could make this get more accuracy, 0.0001. Right, so now it appears to be only 1 dot, but there really are 2 dots here, but they're very close together. They're 14 and 14.0001, but the line reveals the slope of the chord, but effectively, because the difference is so small, we've really got a line that just touches the curve, what is known as the tangent line. So that's very helpful, because we can look here and try 15 and see we're getting very close. The slope is only 0.9. How about 15.3 or 2? Now it's very close, 15.3, but it's positive. The slope is positive, 15.3. The slope is negative, so it's anyway, we've got pretty close. The maximizing value of x is somewhere between 15.2 and 15.3. So the diagram is very helpful indeed. Well, we could use this method, but it's so simple, it's not surprising that it's pretty easy to write down a program which will take the steps that we've just taken. So let's think what the program is going to do. From any starting point, it's simply going to look to the left and look to the right, or be very close and compute the slope. If the slope is positive, the program is going to say the next step will move to the right. If it turns out you go too far, it's going to go back to the left. So it uses this calculation of, here it is, of the slope to determine how to go up to the top of the hill. So let's see how this program works. So you'll never have to do this process again. We can just use to get to the hilltop, we'll need to set this up. File, Options. And we want to add in Solver. It may already be added, but let's check. So we click on Add-ins. There they are. And we need to manage them. Go. Well, I've already got Solver. Suppose you didn't have Solver, this would all be blank, and you could add it in here and say, OK. So now we've got Solver. Here it is over here, and it's on the Data tab. If you were back here on the Home tab, you'd have to go to the Data tab, and there is Solver. So we'll click on Solver. It's ready for help us. So what's the objective? The objective is to maximize profit. So here it is. The objective is cell J10, and we don't want to minimize, we want to maximize, so that's correct. And what's the changing or variable cell? This. So that's what we want to do. There are no constraints. Well, there is a non-negativity constraint. We may as well leave this checked off here because X is an output. It can't be negative. But I would recommend leaving that on, but it won't matter. So that we've got the problem, and now we hit the Solve button. And here's the solution. We can see in the picture that we've got to a point where the slope is essentially 0. It's got 3 zeros and a 0.2. So, and the solution is 15.25. So Solver is a powerful tool, and it's very, very easy to use. Let's look at a second example. Here it is. The price is now 1050, and the cost function has a quadratic, a cubic, and a quartic term. So here's the data. It's 1050 in here, 187 minus 12 and 1.25. And what we'll do is we'll click on the thing we want to maximize, go to Solver. Well, it's the same identical sheet to sheet 3. So what we're trying to do is to maximize profit, changing the cell I10. So everything is fine, and we'll hit Solve. So, OK. And there's the solution, 4.54442. OK, it seems like the solution, but I'm going to try another starting point. Suppose we start at 21, all right? And then we try and use Solver again. Solve. OK. We have a different answer. What's going on? Well, here's the answer. We should have drawn the curve. I haven't shown you how to draw these curves, but I will do so in the next video. But right now, we're just trying to understand issues with Solver. So what's happened in this case? If you know the curve, you know, if you've drawn the curve, you know that the curve doesn't have a single hilltop. It has 2 hilltops. So this reveals what Solver will do. If you start off below this hilltop, as we have here, and click on Solver and solve it, it'll take you to a hilltop. This is called a local maximum. This point 4.544 gives you a height which is greater than any points nearby, a local maximum, but it's not the global maximum. What if we go to a point like this, 15, and try again, go to Solver. This is taking you to the other maximum. So we've got 2 local maxima, and you can see which one is the global maximum. So that's well, Solver is a powerful tool. What it does is climb hills. So if there's only one hill, it'll find the highest point. If there's more than one hill, it'll get to the top of one of those hills. So you need to do a little bit more work to find out whether you really are in a model with only one hilltop, and we'll be discussing that further at a later point.